Topic 3, Day 1, Pythagorean Theorem. The Pythagorean Theorem is a squared plus b squared equals c squared, where a, b, and c are all sides of a right triangle. It's really important to note that the Pythagorean Theorem only applies to right triangles. So we should be double checking that either it tells us in the problem this is a right triangle, or you have your 90-degree symbol on the triangle itself. Now please keep in mind that the C is always your hypotenuse, and the hypotenuse can be found by looking for your 90-degree angle and then determining which side is opposite of that angle. The other two sides are A and B, which are the legs of your right triangle. Now A and B can be interchangeable. It doesn't matter which leg is A or B, but it is very important that the hypotenuse is always C. Now, what's really cool about the Pythagorean Theorem is that it's something that has been known for a very long time, and there are hundreds of different proofs for the Pythagorean Theorem. So one of the ones is shown below right here, where you have the right angle and this triangle in the center. And you'll see that C is your hypotenuse, and C is equal to 5, right? You can count 1, 2, 3, 4, 5. That makes up that side. You'll also notice that A has a side length of 3 and B has a side length of 4. Now you'll see that each of those sides has a square coming out of it. This represents A squared, B squared, and C squared. Now, since A is 3, we know that A squared is 9. And since B is 4, B squared is 16. And it equals C squared, right? C is your hypotenuse. C has a side length of 5. 5 squared is 25. And if you add 9 plus 16, it equals 25. So this is a simple proof that the Pythagorean Theorem works. Now there is a set of Pythagorean triplets. And Pythagorean triplets are when A, B, and C are all positive integers, which means they're whole numbers, such that A squared plus B squared equals C squared, right? So the really common Pythagorean triplet are 3, 4, and 5, which tells us that if 3 is A and B is 4 and C is 5, they are all whole numbers that makes the Pythagorean Theorem true, right? Some of the other ones, 5, 12, 13, and 8, 15, 17 are some of the common ones that you'll see. What's really cool is any multiple of Pythagorean triplets are also Pythagorean triplets themselves, which means if we had 3 times 2 is 6, and then 4 times 2 is 8, and 5 times 2 is 10, that 6, 8, 10 is also a Pythagorean triplet. Now, simplest radical form is a form that is used when we have square roots or other types of roots, and is similar to the process of like reducing your fraction. It is a form that is preferable in writing your final answers. And in order to do simplest radical form, you should think about what factors of the number are perfect squares. So what are perfect squares? Perfect squares are like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, ... so on and so forth, right? When we look at the square root of 72, 72 has the perfect square 36. And then 36 times 2 is equal to 72. But we also know that the square root of 36 is equal to 6. So we can rewrite this square root of 72 as 6 root 2. Now you can always use a calculator to double check. The square root of 72 will give you the same decimal equivalent value of 6 root 2. Any Pythagorean theorem question, unless otherwise stated, should be written in simplest radical form. So teacher example number 1, determine the value of y. So a couple of reasons why I know we should use a Pythagorean theorem here is, number 1, we have a right triangle. And Pythagorean theorem, you always need to find the right triangle. It only works for right triangles. Number 2 is we are given 2 sides and we are solving for another side. All right. The second angles get involved in right triangle problems, we should be considering trigonometric ratio, sine, cosine, tangent. But when we're given 2 sides, we're looking for another side, it is a right triangle, we should use Pythagorean theorem. A squared plus b squared equals c squared. From there, I need to determine what is my hypotenuse. My hypotenuse being my longest side opposite the right angle. In this case, 12 is my hypotenuse, which makes a and b, 8 and y. And again, the a and b are interchangeable. So now I'm going to plug those values in. 8 squared plus y squared equals 12 squared. 64 plus y squared equals 144. Subtract. And then y squared equals 80. Square root, y equals the square root of 80. Now we have to consider, can we simplify this radical, right? Well, I know that 80 can be broken up into 16 times 5, where 16 is my perfect square. So if I rewrite y is equal to the square root of 16 times the square root of 5, and the square root of 16 is 4, y equals 4 square root 5. And we also know that 5 is a prime number. We cannot split 5 up into other factors, so that has to be our final answer. Okay, and of course, we can always use a calculator to calculate the decimal equivalents, and you'll find that the square root of 80 is equivalent to 4 root 5. Try student example number 1 on your own. Teacher example number 2 asks us to solve for x, again, where our final answer is in simplest radical form. Now, in this problem, we should identify we have 2 right triangles, and it shares one side. So once we're able to solve what that side is equal to from using the Pythagorean theorem on our left triangle, then we can use that value to find x. So this is essentially 2 Pythagorean theorem problems in one. So again, I know I can use the Pythagorean theorem because I have a right triangle. And I know that 9 is my C value, which makes 5 my A, and then this line highlighted in yellow, B. So A squared plus B squared equals C squared, and 5 squared plus B squared equals 9 squared, 25 plus B squared equals 81. And then when we subtract, we'll get B squared equals 54, I believe. Wait. 81 minus is 56. Yes. And then B will equal the square root of 56. Now, we can attempt to simplify this radical, but this is not our final answer. It is just something that's going to be used in order to solve for x. So I actually don't have to spend any time simplifying this radical, and instead, I'm just going to go ahead and use the square root of 56 in order to solve for x. Now, in our second right triangle, our right-hand triangle, you'll find that the square root of 56 is our hypotenuse. So now C is also equal to the square root of 56. And then x can be a and 6 can be b. So now we have x squared plus 6 squared equals the square root of 56 squared. And then x squared plus 36 equals 56. Subtract 36 on both sides, and we'll find x squared is equal to 20. So then x is equal to the square root of 20. Now, since x is our final answer, we do have to contemplate how to simplify this radical. And I know that 20 can get broken up into 4 times 5, where 4 is our perfect square. So if x is equal to the square root of 4 times the square root of 5, we can simplify to 2 root 5. And that's our final answer. So go ahead and try student example number 2 on your own.